So from the beginning of kindergarten, you've already learned how to start doing things like adding, subtracting, multiplying, and dividing. And now today you get to learn about a whole new operation. And that operation is now called composition. And so the symbol that you get for that is this little circle where it's you take one polynomial, compose another polynomial. Otherwise it looks like this, where we embed g of x within f of x. And so basically that's the idea, is that we're putting g of x into f of x. Composition is where I'm going to plug one of my functions in for the other one. So I'm basically going to take my 2x and I'm going to plug it in for the x that's in there. So I'm replacing it. So this one right here is x plus 1, and this one right here is 2x. So if I'm going to find f of g of x, what I'm doing is I'm replacing x with g of x. So I'm replacing x with g of x. And so now I have, instead of the x that I had there, I'm going to replace it with what g of x is, so I'm going to put 2x in for that. And so now you see I have the 2x plus the 1 still, and so my answer is 2x plus 1. So let's look at another problem. I have f of x equals 3x plus 2 and g of x equals 2x. So I am going to now, where x is supposed to be, I'm going to put g of x in there. So let's first go, we have 3x plus 2 is f of x, and g of x is 2x. So if I want to find f of g of x, I've got my 3x plus 2, but every time I have an x, I need to replace it with what g of x is 2x. So every time I have an x, I'm going to replace it with 2x. Here's another x, I'm going to replace it with 2x. And one more x, I replace it with 2x. So on math, it looks like this. Instead of the x, I'm going to replace it with 2x plus 2, which is what I have, and 3 groups of 2x, which is what I have there, is 6x plus 2. So as you saw with the blocks, we're taking one polynomial and we're putting it into the other polynomial. And I know we've already seen this one with the blocks, but let's just go over it again. So when I have f of g of x, the outside function is f, and so that's what I'm going to copy down right away. So I'm going to copy down this 3x plus 2. But what I'm going to do is, instead of the x, I'm going to put parentheses and then plus 2. And then I can focus on what is inside of f of x. So inside is g of x. So I'm going to take what's inside, and I'm going to plug it into that parentheses. And now I just do that math, so I get 6x plus 2. Now on this next one, it's the other way around. We start with the outside function of g of x, so I'm going to write 2 parentheses. And then inside of it, I'm going to plug in f of x. So I'm going to take f of x and I'm going to plug that in, 3x plus 2. And I do my math, 2 times 3x is 6x, 2 times 2 is 4. And so that's pretty much, not substitution. It is just like substitution, but that's what composition is. So now it's just a matter of us practicing a bit more. Here I have a little bit more complicated. Remember what a negative exponent does. A negative exponent is going to take whatever this is and it's going to move it down to the bottom. So here I go. I'm going to start with my outside function, f of x. So I'm going to write 3 parentheses to the negative 1. And then I'm going to take my inside function, 2x minus 1, and I'm going to put that on the inside. And now it's a matter of doing my math correctly, and that's very important here. So I can't take 3 times this stuff because I have an exponent. And when you have an exponent, you have to deal with that first. Also, I cannot distribute my exponent because I have a minus sign in there. You can only distribute if it's multiplying or dividing. So what I'm going to do is I'm going to utilize the negative exponent, which means I need to take all of this and move it to the bottom. So then this equals I still have the 3 because the 3 hasn't been moved, but I'm going to move 2x minus 1 to the bottom. So it's really an easy move, but sometimes we mess up on that. All right, let's go to the next one. So the next one, my outside function is g, so that would be 2x minus 1, and instead of an x I put parentheses. And then I plug in f of x. F of x is 3x to the negative 1. Now notice where that exponent is. The exponent's on the inside, and it's just for the x. So it's okay actually to take that 2 times the 3 because the exponent is inside, not on the outside. So I go ahead and do that math. 2 times 3 is 6. So now I have 6x to the negative 1 and then minus 1. And the last step is to deal with that negative exponent. Remember, it's just the x to the negative exponent, so that x needs to go to the bottom. So now I have 6 over x and then minus 1. And the next one's kind of a fun one. This one is a function inside itself. So I have f on the outside. That means I need to write 3 parenthesis to the negative 1. And then I have f on the inside, so in the parentheses I'm going to put 3x to the negative 1. Now remember talking about exponents. We can take that negative exponent and we can distribute it only because it's a multiplication inside. So I am going to take that negative 1 and distribute it to both of them because it's a multiplying inside. I'm not going to work with this 3 yet because I have to take care of the exponent first. So I still have that 3. I still have that 3, and then I have to distribute that negative 1, so it'll be 3 to the negative 1, and then negative 1 times negative 1 is 1. Okay, now I don't have an exponent on the outside, and I can do some more math here. So I take a couple ways you can do this. Some people want to move that 3 down to the bottom because it's a negative exponent. What I see is that I have 3 to the 1 and 3 to the negative 1. If I add exponents, I get to the 0. X to the 1, and then 3 to the 0 is just 1. So really my answer is just x. Now, next you see this word domain. Domain means what x values are okay and what x values aren't okay. So what is the domain of each? So I'll do this in red and go up to each problem. So remember, you can have just about every x value. The x values you can't have are the ones that make the bottom equal to 0. And since I have an x on the bottom, it's possible to get 0 on the bottom. See, if I take the bottom and set it equal to 0 and solve, so add the 1, divide by 2, if x equaled 1/2, the bottom would equal 0, and that can't happen. So for the first one, my domain is all x except x equals 1/2. Okay, whoops. Okay, for the next one, again, I'm looking when is the bottom going to equal 0. And there the bottom will equal 0 if x is 0. So my domain will be all x except x equals 0. And for my last one, notice this one doesn't have a fraction at all, so there is no way to make the bottom equal 0 because there's no bottom to work with. So my domain then is going to be all x. Everything was going to work. All right, so for your notes, I want you to do these last 3 here. Okay? For your notes, I want you to find f of g of x, g of f of x, and f of x. And these are some of the things that I'm going to be looking. And I also want you to look at what is the domain of each.